Alright, so now let's take a look at Chapter 12, problem number 14. The problem reads, a uniform ladder of length L and mass M1 rests against a frictionless wall. The ladder makes an angle theta with the horizontal. A. Find the horizontal and vertical forces the ground exerts on the base of the ladder when the firefighter of mass M subscript 2 is a distance x away from the bottom. B. If the ladder is just on the verge of slipping when the firefighter is a distance d from the bottom, what is the coefficient of static friction between the ladder and the ground? Now we need to identify the givens. In this particular problem, they did not give us a set of numerical values, but instead they gave us variables. They gave us L, a length of the ladder, theta, the degrees that the ladder was leaning against the wall, the mass of the ladder, the mass of the man, and how far the man was up the ladder. Next, we have to identify the find. In part A, they want us to find the sum of the forces in the x direction as well as the sum of the forces in the y direction. In part B, they want us to find the coefficient of static friction, which is given the variable mu sub s. Now we need to take a look at the equations. The sum of the forces in the x direction is equal to the friction between the ground and the ladder minus the normal force of the wall. And because the ladder is not in motion, this is equal to 0. In the same way, the sum of the forces in the y direction are equal to the normal force of the ground minus the mass times the gravity of the man minus the mass of the ladder as well. This is also equal to 0. Lastly, we need to find the sum of torque about the axis. This equation is equal to a negative mass of the man times the gravity multiplied by the length of the ladder divided by 2 cosine theta, subtracted by m2 multiplied by g times x times cosine theta. And then these two are added to the normal force of the wall multiplied by the length of the ladder and multiplied by sine theta. And again, all of these forces are equal to 0. Using some basic algebra, we find that the normal force of the wall is equal to 1/2 m1g plus x over L m2g. This is also multiplied by cotangent theta. Now, taking this equation of the normal force of the wall and plugging it into the sum of the forces in the x direction, we can solve for friction. We now know that friction, which is equal to the sum of, or the normal force of the wall, is also equal to 1/2 m1g plus x over L multiplied by m2g cotangent theta. taking the normal force of the wall equation and plugging it into the second equation, we want to solve for the normal force of the ground. And using some basic algebra, we can find the final answer will be m1 plus m2 multiplied by g. These are your answers for part A. Now we need to solve for part B. Because the ladder is on the verge of slipping, this occurs when x is now equal to d. We want to find the coefficient of static friction. The equation for this is mu s equal to friction itself while x is equal to d over the force of the ground. When we plug in everything from equation 1, we can find that m1 plus m2 for the normal force of the ground goes under m1 over 2 plus m2 times its new distance over L, the length of the ladder, multiplied by cotangent theta. This is your equation and answer for part B.